Okay, so it cut me off in the middle of this problem. So we're going to start here solving this quadratic, and we agreed we need to use the quadratic formula. So we say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know from here a is 1, b is 4, and c is 16. So I'm going to plug those in. So I have negative 4 plus or minus the square root. 4 squared is 16 minus 4 times 1 times 16 all over 2. And we can tell that's going to be negative up under the square root. So I have negative 4. So I have negative 4 plus or minus the square root of 16 minus 64 over 2. Which is negative 4 plus or minus the square root of 48, negative 48, which is negative 4 plus or minus the square root. I know that 48 is 16 times 3, so when I take the square root of 16, I can bring out that 4, so 4i times the square root of 3 all over 2, and now I'm going to reduce. And I get negative 2 plus or minus 2i times the square root of 3. So when I solve that quadratic, that negative 2 plus or minus goes with this, so that the answers are 4 and then negative 2 plus or minus 2i times the square root of 3. Those are the solutions for number 12. So it was a cubic, right? Cube. Polynomial, and I did get 3 roots. So if you're going to list your complex and your real roots, then the total number of roots you get should add up to the degree of your original. All right, number 13 is going to be very similar to number 12. So we notice it is a sum of cubes. So I know that the cubed root of x cubed is x. The cubed root of 27 is 3. So I do my small set of parentheses and my big set of parentheses. And I have x plus, sorry, I won't do my signs yet. So I'm going to put in my 3, and then I square the x, I square the 3, and then I multiply them together. And now I know I keep the first sign the same. Then I do the opposite, and then always positive. And that equals 0. I'm solving to find the x-intercepts, or the roots. So I take each one of those factors. I have 2 factors right now. And when they multiply to give me 0, I said each one of them equal to 0. So I get x plus 3 equals 0. And I get x squared minus 3x plus 9 equals 0. So x equals negative 3. And then again, I'm going to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then I have 3 plus or minus the square root. I have 9 minus 36. 9 minus 36 was that going to be 27? Negative over 2. And again, 27 is 9 times 3. So that gives me 3 plus or minus 3i times the square root of 3 over 2. So I have those 2 roots along with that as the solution. And again, we can rewrite that. It could be 3 halves plus or minus 3i square root of 3 over 2. And there's different ways you can write that I. You could have that little piece could be 3 square root of 3 over 2i if you were writing it truly as a complex number. All right, last one. Number 14. So I look at this one. There's no greatest common factor. So I check that box. It has 3 terms. So I think of it, it is a trinomial. And so I want to ask myself, could it be quadratic? Is there a way I can treat this as a quadratic? And I look at the degree. So the middle term, the degree, is half the degree of the first term. So I should be able to factor this as if it's a quadratic. So let's try. And again, then that would make that x squared and x squared. Because I know if I write this as a quadratic, I have that being squared minus 33 times that same stuff. The key is you have to be able to write it so that this piece and this piece match, and they're both in there. Because that way you have it, that yellow stuff is being squared, and then it's being to the first power, and then in the last term, it's to the 0 power. That's how you know you can write something as a quadratic. So that would be x squared to the 0 power, which is just 1, right? So just wanted to kind of make that clear. That's really what we're doing, is we're 2, 1, 0. Writing that as an exponent. Okay. So when I get back to this, now I'm looking for two numbers that multiply to give me 200 and add to give me negative 33, and they add to give me negative 33. So think of numbers that give me 200. They both have to be negative. This is when I should get my thoughts together before I start videoing, because now I've got to think about my numbers. So of course it could be 10 and 20. That doesn't work because that gives me negative 30, but it's pretty close. So if I do 8. Hold on. So we said we're going to try 8. Sorry, I had to do something real quick. So if we do 8, we think of money, right? Like quarters. So $2 or 200 is 8 quarters. And sure enough, if we make both of those negative, we get negative 33. So I'm going to put a negative 8 and a negative 25 in here. And now I can solve both of those. If I have x squared minus 8 equals 0, I set that equal to 0. X squared minus 25 equals 0. And now if I have x squared equals 8, x squared equals 25. Let's take the square root of both sides. And I get x equals plus or minus the square root of 8. X equals plus or minus 5. This has a perfect square in it, so be careful that you remember to simplify. That square root of 4 comes out as 2, so I have plus or minus 2 times the square root of 2 and plus or minus 5. 4 roots, and again, it was a 4th degree polynomial, so I was able to find all 4 roots, and they're all real solutions. So, but think about what we learned at the beginning of the section. We know it's an even degree, so both ends are going to be up or down. A is positive, so I know both ends are going to be up. It crosses the x-axis 4 times, right? So negative 5, and it comes back, and then this one happens to be, there we go. Something. I mean, that's a sketch. Remember, I did not try to graph it exactly, but that's a vague representation of what it might look like. So, all right. Well, I hope this helps kind of go over those homework problems. Try the ones for tonight's homework and see how you do. And we'll talk about them in class tomorrow. Bye. I hope you guys had a great weekend in the non-snow.